Thank you very much. So let me get started here. So yes, I'm going to talk about CI/CD and more specifically Tekton. So more and more, and I'm guessing this is an automation conference, so probably everybody's somewhat familiar with CI/CD. But I'm going to show you how you can integrate your CI/CD pipelines directly inside of your Kubernetes cluster today with Tekton. So it's a cloud-based or cloud-native CI/CD framework that you can use. And I'm going to try to show you a very hands-on presentation. So I don't have a lot of time. Actually, I should start my timer. But I'll try to kind of show you how you can actually create your pipelines using Tekton inside a Kubernetes cluster. So Tekton uses concepts called tasks and pipelines, and you can basically use them as Lego blocks to build your big CI/CD pipelines. And I couldn't help to make an association between clouds and pipes, and I said, well, why not make a Mario Brothers theme talk, because there's pipes and clouds. So all right, so let's get started with our presentation today. First, let me introduce myself. So hi, my name is Joel. I work as a developer advocate for Red Hat OpenShift. If you ever want to reach me, Twitter is always the best way. So Twitter is Joel with 2 Lord. That's always the best way to reach out to me. I'm a big fan of Twitter, so I always answer really, really quickly if you have any questions. I'd be more than happy to help you out. And I will also tweet slides and links for to actually try out Tekton at the end if you'd like. So follow me on Twitter if you want more of that information. So to define CI/CD, just to make sure everybody's on the same page, Red Hat, I think, has a very good page that kind of describes everything about CI/CD. You can take a look at that. Once again, I'll share the link at the end. But CI/CD introduces ongoing automation, continuous monitoring throughout the life cycle of apps, from integration and testing phases to delivery and deployment. So basically, you can put that inside a small, chart to make it cute. So CI really is continuous integration. It's an automation process for developers. So if you have successful CI, it kind of means that whenever you do a code change to an app, you will rebuild and retest everything and re-merge everything into a shared repository. So you can automate all of that stuff immediately. And a lot of people have been doing a continuous integration even for the last few years now. Now, CD is a little bit more recent. CD really refers to continuous delivery or continuous deployment, depending on how you look at it. They're both related concept, but sometimes we like to split it just to show the amount of automation that is happening behind the scenes. So when we talk about continuous delivery, it means that developers' changes to an application are automatically bug tested and uploaded to a repository where they can then be deployed to a live production environment by the operations team. So it's an answer of the problem of, when you have poor visibility and poor communication between dev and business teams. So it really helps with that. The continuous deployment part, or the other possible CD, can really refer to automatically releasing a developer's changes to the repository, from the repository to production. So where it's usable directly by customers. So really, when you commit your code, it'll go to the steps of process of building, of testing, of merging into your repo, releasing to a repository, and then deploying to your production server. And all of that should be automated, ideally. Of course, you want to make sure that you don't deploy an application without it being tested, right? But you can automate all of that process. So I said already that Tekton is a cloud-native framework for CI/CD. And what do we mean by cloud-native in that context? Cloud-native is pretty overloaded a term. So what it means in this context is that it means that we'll use containers. So we'll support the apps that run in containers and that are orchestrated by Kubernetes. So everything that will happen in Tekton will happen in its own container. It must be serverless, and I'm not talking about serverless without servers or Lambda functions here, but I'm talking that it should run and scale on demand without the need of a central CI engine that has to be maintained and taken care of by the DevOps, or BM that has to be taken care of. So really, all of that should be automated, and you shouldn't have to worry about the infrastructure. And finally, it should be built with DevOps in mind or DevOps practices in mind, and allow teams to own their own delivery pipelines alongside the application without having to rely on a central team of excellence that manages delivery pipelines. So ideally, you want your developers to be able to own all of that and to be able to deploy your applications on yourself. So we want to be able to build, test, stage, deploy everything with those characteristics in mind. And this is what will lead us to Tekton. So Tekton is one of the many CI/CD frameworks that is available. Others are Jenkins, Nginx. You can take a look at cd.foundation, where is a foundation for all continuous delivery projects that is available. So you can take a look there, but I will focus on Tekton primarily because it has the coolest logo. That's what I think, at least. No, more seriously though, it's because it's so easy, because it has composable and reproducible, declarative and cloud native structure. So basically what that means is that you have all those little blocks that you can use and reuse to compose your large pipeline. So you have smaller tasks and you build all of your pipelines with that, and you can reuse those pipelines just by changing the inputs or the outputs. So let's take a look at this. So right away, we'll jump into some code examples, just so that you can get a feel of what a Tekton pipeline looks like. And of course, I'm going to keep my Super Mario theme. So let's just blow in that cartridge and get started. So the first thing you'll need, of course, is a Kubernetes cluster. I will be using Minikube for the demos that I'm going to show today, but it works with any Kubernetes cluster. If you're using OpenShift already, it actually integrates, and it's called OpenShift Pipelines. So it's part of the OpenShift UI as well. So what you need to do, the first thing is to install Tekton's CRDs. So you'll just run a command. So you'll run an apply. It will download the YAML file from the GitHub repository from Tekton, and it will install all the different CRDs that are needed, and you're ready to go. You're ready to use Tekton already. The other thing that you'll probably want to use is the Tekton or TKN CLI tool, which is also relatively easy to install. So you can take a look at how to install Minikube and Tekton CRDs and the CLI at this address right here. Once again, I will share my URLs at the end. So why don't I get started with one of the basic building blocks in Tekton that you will be using if you're using Tekton, and those are called tasks. So tasks. So a task is basically one thing that you want Tekton to do for you. In this case, I'm going to create a CRD, or not a CRD, but a task object in my Kubernetes cluster. And by the way, if you have any questions, I'm kind of monitoring with one eye the chat right there. So feel free to ask any questions. So I'll create my first task. So I'm going to use, and building tasks is just like building any other Kubernetes object. So if you're familiar with Kubernetes already, this YAML file shouldn't be too strange to you. So you've got API version. It's an object from tekton.dev/v1 beta 1, which was released about just a few months ago, maybe 2 or 3 months ago. We'll create an object of kind task, and we can specify some metadata. For now, I only need a name, so I'll call it start game. And the bulk of my task will be in the spec. So for my spec, if I can find my mouse again, for my spec, I will have an array of steps, and we'll get back to steps in a second. But my first step will be called press start. I will use an Alpine image. So as I mentioned, all of those steps, all of those tasks, everything will run inside their own containers. So I will use an Alpine 3.12 image, and I will simply echo a starting game. So instead of playing Hello World, we'll just start a Mario game. So basically what it looks like, I already have my YAML files already there. So kubectl apply. So we simply apply this to our Kubernetes cluster. We can see that our start game task is created, and I can use the TKN CLI tool. Is that large enough? Let's just make it a little bit bigger. TKN task, start game, and start. And we'll show the logs, show log, and TKN, oh, I always get the structure wrong. Okay, start game, show log. There it is. All right, so we are starting our task. And what happens now is that it's actually downloading the Alpine 3.12 image. Of course, I already had it, so it's a little bit faster. Once it has that image, it will run the command that I asked it to run, which is just an echoing starting game. And you can see that this was outputted by my task. Press start. So we've got our first task created. So congratulations, you are now a Tekton expert. You can create your own tasks and get started with those. Now, I've already said, I've already talked about steps. So we don't just want to start a game, right? Part of the process of starting the game is, well, we need to select the players and then press start. So there's two little steps here. So a step is really the simplest, the basic unit of your pipelines. And each one of those steps will run in their own container. So if I take my last example again, and I try to tweak it just a little bit. So instead of just having my press start as I had before, so everything up to here is the same. And then I have my press start step, which I previously had. So I'm going to add a second step here, which will be called select players. I'm still going to use an Alpine image and just echo selecting players. So, oops, whoa, going too fast. So if I go ahead and try to apply this, kubectl apply. All right, so I've changed my task. You can see that it was configured. So tekonn task start game, show log. There it is. Okay, so now you should see something very similar once again. It will run both of my tasks, or both of my steps inside the same task. And you can see the name of the steps this time. So select players and then press start. And you can see that they all happen. And every one of those steps happen in their own separate container. Good. So now you're able to create tasks, and you can create tasks that have multiple steps. So you can imagine those tasks being a little bit more complex, right? Maybe you want to lint some code or to build your application. So of course I was using a single command, just an echo, but that was just to kind of show the core of the task, not the actual task. So one thing that you can also do is to add parameters to your tasks. So to add parameters, you will add a params object or a params array to your spec object. And for this one, I have one parameter that is called players. The description is number of players, default is 1, and it's of type string. In my step called select players, I will add just one tiny little thing here. So instead of just outputting selecting players, I'll actually selecting params.players players. So you can actually read the content of that parameter and use a string interpolation to inject that inside your commands or inside anything. So if you had a git clone task, for example, well, you could use a parameter for the URL of the task, and you can just inject that inside the git clone command. So you'd be able to clone and reuse that task by simply changing the parameter. So what does this look like? kubectl apply. Third one. And let's start this task again. Tekonn task start game show log. All right. So value for parameter players. Let's say 2 players. And you can see value is 2. And we should see pretty much the same output as before, but now we have selecting 2 players and starting game. If you're using tekonn, the command line tool, you can also pass parameters -p players equals 3. I know that doesn't really happen in the original Super Mario Brothers, but let's just do it for the sake of this demo. So you can have selecting 3 players, or I can just use showlog and use param defaults. I think it is. All right. So that will force to use the defaults. So that in this case, it will just output selecting 1 player. Good, so we can now add parameters. So you can see how our tasks are coming more and more versatile, and you can reuse those tasks in various contexts. So this leads us to pipelines. And now I'm going to show you a little chart just that kind of describes everything that I've shown you so far. So a pipeline is a collection of tasks that will run into a specific order. So each task, as you can see, are composed of multiple steps. So I have task A here that has 3 different steps, and then it will, once executed, it will run task B and C. And then once they're both executed and successful, it will run task D. You can find out more about the global concepts of pipelines, tasks, steps, pipeline resources, and a lot more at tekton.dev/docs/concepts. So to create your first pipeline, what we're going to do is that we will create a series of steps or a series of tasks that will lead to Mario defeating Bowser, right? Because that's what Mario ultimately wants to do. So the first thing that we'll want to do is to create this specific task that will defeat Bowser. So the step here will be to defeat Bowser, and it will just echo battling Bowser, pause for a second, and then echo you won. Now onto our pipeline. So we want to play Mario for our pipeline. So we will create an object. Again, we'll use tekton.dev/v1beta1. We will create an object of kind pipeline, and we'll give it the name play Mario. In our spec, we will have a tasks array, and our task array will have multiple tasks. So the first one we'll call start, and it is a reference to the task that was called start game. So the task that we've built earlier, the ones where we are selecting players. You can even pass in parameters for that specific task inside of this tasks array. So right here, I'm specifying that this will be a game of 1 player. Now I also have a second task, which have multiple steps on it of its own. And that second task is called win, and it's a reference to the task defeat Bowser that I've just created. So what does this look like? kubectl apply. Ooh, I don't have enough time to make typos. So we'll apply that one. So this one created the task, and let's create our pipeline. And there it is. So if I do tekonn pipeline ls, I can see the pipelines that I have. So I have a play Mario pipeline here. And why don't I go ahead and do tekonn pipeline start play Mario. There you go. Oh, of course, I forgot to show the logs. Show log. Okay, so now it started. We've got our pipeline. It's going to execute all of the tasks, all of the steps. So we've got 2 tasks, 4 steps, and you can see them being executed. You see the name of the task followed by the name of the step. And you can see that we have a small little problem here. We start by battling Bowser, then we sleep for a second, and during that time, we select 1 players, you win, starting game. So everything is kind of mixed up. We don't have the right order here. So you have to be careful when you build your pipelines to make sure that your task sequence is in the correct order, or else you get some glitches like we just did. So to change that, I will take that same pipeline in my tasks array. I have that same task. The first one, start, is a reference to start game. And for my second task, I will add run after start. So I'll tell Tekton to make sure that this task only runs after task 1 is successful, or after a task start is successful. So now what do I have? kubectl apply. I think I'm at 6. And we will run tekonn pipeline start play Mario show log. Whew. All right. So what we should have now is that we'll have all of our tasks running one after the other. So we've got task 1, the task start, and we've got our 2 steps in here. And then we've got our task win, and followed by, actually there's only 1 step into the second task. As you can see, it has the same name, and you can see them appearing one after the other. So we're getting good. We're getting really good now. But there's an interesting thing that you can also do, and that is part of the core concepts of Tekton. It's the concept of reusable tasks. So you can create tasks that with some parameters, you'll be able to change the nature a little bit so that you can reuse them even across a single pipelines or across multiple pipelines if you want. We can also run different tasks in parallel. So right now, we've just made sure that they run sequentially one after the other, but you can also run some of them in parallel. So the first thing I'm going to do is that I'm going to create a new task. That task will be called collect, and it will have 1 parameter. The parameter would be for the object that we want to collect. By default, those will be coins, because that's what Mario does, right? He collects coins. And then the step will be to just echo once again. What I'll do is that I'll get a random number. I'll sleep for that number of seconds, and then I'll echo that we've collected X many coins. Now, in my pipeline, what I can do is that I can add a new task, and I will add my task collect coins, and it's a reference to the task collect. So it will output collecting 3 coins. Now I'll add a second task, which will be collect mushrooms. It will be a reference to the same task. So you can see here that the task ref is the same. But in this case, I'm passing a parameter that will say, well, collect mushrooms, because Mario also collects mushrooms. Another thing that I'll want to do is make sure that they run after start. So I'll start by the start task, and then I will run those two collect tasks. And finally, I will run my win task. And this one, the run after, is an array. So you can specify more than one. So it will actually run after both of those tasks are completed. All right. If you have VS Code, there's an extension called Tekton Pipelines, which I really, really like. It enables you to preview those tasks very visually. So I really like that tool. And you can navigate through your different pipelines and so on. So we can see here that we have our start task. We will collect mushrooms and coins at the same time, and then we will execute the task win. So what do we have so far? kubectl apply -f. I believe it's 7 now. So we've created our task. We've got our pipeline. So TKN pipeline, start, play, Mario, and show log. Okay, so now we're running this time. And we have a start, and then we should have in simultaneous those two collect tasks. So we've got our two containers running, performing that same operation. So the first one was a little bit quicker, picked up one mushroom along the way, collecting 2 coins along the way. And then we have our final task. If I run it again, because those numbers were random, coins might come in first after, and then mushrooms. But ultimately, the thing that you'll notice is that we always have the start task, then the other two tasks, and finally we have the win task. I got the same numbers. Now you're not going to believe me that it was random. So one of the things that also came out from the fact that you have reusable tasks is the task catalog. So Tekton provides you with a bunch of tasks that are pre-made already, available to you. There's a hub that is available, but it's still in a beta, so it's in preview mode, but hub-preview.tekton.dev, and you can find multiple tasks. So if you need to do a git clone, it is already there. It's already made for you, so you can use those. Another concept that I want to introduce is pipeline resources. Now, pipeline resources were kind of useful. They're still in alpha, so it's still unsure what is the final status is going to be of. But basically, it's just an input for your pipeline, and then you have an output for your pipeline. So you could input a GitHub repo and have an output of an image, for example. But it seems like it's going to be replaced by a concept called WORKSPACES. And WORKSPACES, although a little trickier to use, are basically a shared persistent volume between all of your different tasks. So I could do something like have a reference to my my workspace and then find a file level txt, so I can start from a specific level or read that from a file, and that file could come from a git clone repository before. I'm running out of time, so I'll go a little bit faster. kubectl apply. Let's see if I can actually do it. Yeah, apply -f8, and we've got our persistent volume, our persistent volume claim that were unchanged because they're already created, and then I have my level selector pipeline that I've just created. If I do tkn pipeline start level selector show log. Okay. So I'll need to specify a name for, I'll need to also kubectl apply, and I have the git clone task from Tekton. So name of the workspace will be level ws. The subpath, I will leave the default. I will use a PVC, and I believe the name is tkn PVC. So let's see, and I'm having issues right now, and I have less than a minute to debug that, so I'll leave it for now. But what happens now is that you can clone that repository and read the content of a file. If you need to do a real world pipeline, well, basically you would reuse the exact same concept that I've just shown you, but you would change a little bit your task, right? Of course, instead of just using echo statements, you would do steps like cloning a repository. And then in parallel, you can perform some unit tests and perform some code linting. And then if both of them are successful, you can go on and compile your code, and then finally build an image and deploy that to your cluster. So this is what a real world example would look like. So just to recap, cloud native CI/CD framework, Tekton, amazing to work inside of your Kubernetes cluster. It uses steps, tasks, pipelines, and workspace. So hopefully you're now powered up. You know a little bit more about Tekton. If you want to find out more, there's a lot of links that are available to you at easyurl2/pipes and clouds. Thank you very much.